Hi friends, welcome to BSpice, Bala School for Process Instrumentation and Control Engineering. This is Rambala with you. In this video, we are going to discuss about how to prepare data sheet for a control valve. So before going into the course content and details, I just want to request you all to read through the previous videos uploaded on mastering P&ID. It was uploaded on 3 parts. Okay, because the reason is in this section, there are a lot of things we need to refer back to P&ID for inputting the data into the data sheet. Okay, friends, thank you again for all your support. Let's get started. So in this datasheet control valve preparation, we are going to deal with general information, pipeline details, process conditions, calculator results, selected results. Here I just want to tell you, in some cases, this 4 and 5 is same only, but now just for your, better understanding, I segregated the calculated results, meaning this is the internal calculation performed by us or by an engineering company or EPC while doing the calculation, and selected results is the one which we receive from vendor after their calculation. Okay. Then number 6, body and trim. Then number 7, actuator. Number 8, communication and software. Then number 9, positioner. Number 10, solenoid valve. Number 11, switches. Number 12, asset. And number 13, purchase details. In addition to this, there is also a section, special requirements. Okay, we'll see all these 14 aspects in the upcoming slides. Okay, friends, I think the agenda is clear. Okay, before going on to the details, I just want to show the typical data sheet so that the beginners can have a better feel of it. Of course, the experienced engineers, they all aware, actually, they are doing day-to-day, the control or data sheet preparation. But this is purely for the beginners. Okay, friends. Okay. So this is the, due to the size of the data sheet, I just, segregated into 3 parts. Okay, you can see here as a general. So under general information, you can see tag number, plant area, service, line class, P&ID number, area classification, tightness requirements, meaning the leakage requirements, then pipeline. Under pipeline, we have a line number, line size, pipe schedule, pipe material, insulation, inlet and outlet size. Then we have the main thing, process conditions. So you need to, don't have to worry about this. This will be given by our process colleagues. So you can always request for them. Once they give, you can fill in the details. For example, process fluid state, design pressure, maximum, minimum flow rate, inlet pressure, pressure drop, inlet temperature, density, compressibility factor, if any, inlet viscosity, and specific heat ratio, vapor pressure, inlet critical pressure, shutoff pressure, flashing requirement, all this. And additionally, I add in 2 more items, fire safe design and fire safe standard. Okay, friends, I think hope you got some insight on the look and feel of the data sheet. This is the first part. Then in the second, we'll continue. Yeah. So they, again, as I highlighted earlier in the beginning, calculated sheet results and also the selected results. So both, if you can see, both the parameters are same, but only difference is this is what we are going to input when we do the preliminary design. Then subsequently, after the vendor do the calculation, so we will get all those data and fill in here. Okay, friends, I hope it is clear. Then we move on to the body and trim. You can see here, manufacturer, body type, body size, rated CV, end connection and rating, body material, bonnet, flow direction, gland packing, lubrication, guiding, trim type, plug, ball, disc material, seat material, gauge, guiding bush, stem material, NAS compliance. What is NAS? We'll discuss all these in the detail, okay? gasket material, stat board, flow action, that's a flow direction, then body color. Then we have a positioner details, manufacturer model number, signal, increase signal, valve, then cam characteristics, bypass requirement, gauges, connection size, certification and IP rating, and external position transmitter requirement. Then we have a solenoid valve, manufacturer model number, type, quantity, de-energizing requirement, tag number, power consumption, external reset required or not, and the voltage rating, speed controller, certification, housing material, and of course the electric connection size, coil insulation rating, all these stuffs. Okay, so this is the second part of the data sheet. Then the final part, you can see here actuator data, again manufacturer model number, type, size, actuator IA design, pressure, air failure action, action on air, power failure, of course both are one and the same, hand wheel location, bench range, actuator color, travel limit if any, fireproofing requirement, IP rating, volume tank requirement for additional strokes, and lifting hook, travel indicator, all these stuffs. Then comes the communication and software. What's a communication type and functional block, and whether valve asset management software requirement, compatibility with plant automation system, then LAS capable, that is link active scheduler, and DD revision and ITK. Okay, all these stuff we are going to see. And additionally, we have some other things called like switches. For example, what is the contact rating, switching position, tag number, quantity, certification and IP rating, connection size, housing material, etc. Then we have the asset, air filter regulator, manufacturer model, set pressure, filter, input and output gauge, housing material. In this case, it's aluminum. Like this, all these stuffs, and of course the purchaser details. And in addition to all this, we also have some special requirements we'll be dealing in the subsequent slides. Okay, so the data sheet, I hope the look and feel of the data sheet is clear, especially for the beginners. Okay, friends. Okay, now we'll move on to the main topic. Okay, general information. Under general information, tag number. So where we can get the tag number? Of course, refer P&ID and insert the tag number. Then plant and area, where we can get, again, refer P&ID and input the respective plant area and area description with unique number. That's why I told earlier in the beginning of the video, you have to refer the P&ID. P&ID, better to go and read that so that you will know how to read the P&ID and where we can plug in all this data. Okay, so for example, in this case, plant area. So plant area, for example, SCU. What is that SCU? Yeah, furnace feed, cracking, heater. Okay, SCU here is steam cracker unit. Basically, I come from the refinery background, so I predominantly I use this nomenclature. Okay, then service. Again, refer to the P&ID and input the service description. For example, F2001 dilution steam piping. So this information. Then comes the line class and P&ID. Where we can get the line class? Of course, we have to refer the P&ID for the line class. If you remember the earlier video, I have put one page exclusively for this, for line designation. So you have to pull out that from the P&ID reference. Okay, in this case, I just put A1A1. Of course, what is A1A1? We need to refer the piping material specification and see what is it. Okay, then the P&ID number. So these are things in general information. We'll move on to the next slide with few more information. Okay, yeah. Few more is hazardous area classification. This is very, very, very important information which we need to put in the inside the data sheet. You have to refer this from electrical team or process team. Some company electrical take care of this, some companies the process team. So this is basically the input document for an instrumentation team. So here I want to say some very critical items. So in a refinery or a petrochemical plant, there are generally processing flammable fluids. Hence, majority of the area where instruments are located will be zone 2 area classification or zone 0 or zone 1. Okay, it purely depends on the hazardous area map. Okay, so that is the first thing actually, hazardous area. So for our freshers actually, I hope you know what is zone 0, zone 1 and zone 2. See, zone 0 is an area in which an explosive atmosphere is present continuously for long period of time, or we can say it's a frequently occur. Okay, then zone 1. What is zone 1? Zone 1 is an area in which an explosive atmosphere is likely to occur occasionally in normal operation. It may exist because of repair, maintenance, or leakage, like that. Then zone 3, zone 2. Zone 2 is a place in which an explosive atmosphere is not likely to occur in normal plant operation. But if it does occur, it will persist for a short period only. So these areas only become hazardous in case of an accident or some unusual operating condition. I hope, friends, you got what is zone 1, zone 0 and zone 2. Okay, so that things you need to input here. So, okay, before going in detail the next item, I also want to highlight here, in addition to the hazardous area classification, zone 0, 1 and 2, we also need to input the gas grouping, like for example, 2A, 2B, 2C. Okay, for example, you can say hydrogen gas presence. So it will fall into any of these actually. Okay, and also in addition to the zone and the gas grouping, we also need to take care of what do you call the flame proof requirement actually, right? So you can put a flame proof requirement or otherwise in line with the project specifications. Okay, what is required, right? Flame proof, explosion proof, all those stuffs in line with the project specification. Of course, you will get all this data from the electrical or process team. You will find everything in the hazardous area classification trial. Okay, then we go to the leakage or tightness requirements. This is also very important item for a control valve. Basically, we need to refer to project specification for this information. Okay. So we need to select the appropriate valve leakage class and input in the data sheet. Of course, this tight shut-off requirement will come from process team. Our process colleagues will support, and it should be in line with FCI 70 part 2. Okay. So we need to confirm whether there is a tight set-off requirement. If it is tight shut-off, we call it as TSO. Then we should put it as class 5. Otherwise, it falls under class 4. Okay, friends? Hope it is clear. Okay, just for for your additional information, I also added here the leakage requirement in line with the class requirement, in line with the class categorization. For example, take the case of, I think we will go into the from the bottom, class 6. That is the very stringent requirement. So we need to refer to the IEC standard 60534 part 4 and table 3. Okay. And for class 5, I have defined it here. No more leakage than 10.8 into 10 power minus 6 into D nm cube per hour. Okay. D is the diameter in mm. Okay. Then you have class 4. Class 4 is no more than leakage 0.01% of rated flow capacity. Then similarly for class 3, not more leakage than 0.1% of rated flow capacity. Class 2, no more leakage than 0.5 of the rated flow capacity. Of course, class 1 and 2 normally we don't use this class 1, 2, 3. So basically start with class 4 and it goes beyond. If it is tight shut off, we'll go for class 5 and class 6. Okay, friends? Yeah, we'll move on to next item. So now we'll focus on pipeline details. Okay, so in the pipeline details, what first item is a line number. So what is this line number where we can pull out? Okay, if you refer the previous course, P&D course, you can see the line schedule list. So from there, you can pull out this data. For example, in this case, P60210,551, then followed by the 6-inch, that is the line size, then followed by the piping class. Okay, and also this insulation rating. Okay, so that's for the line number. Then line size. Again, we need to refer to the P&ID and input the size. So in this case, we have both line inlet and outlet. So example, it is 5-inch, 4-inch in this case. I just put it in an example actually. Okay. Then piping schedule. Refer the piping class from piping team. This will be given by the piping colleagues. You can always request for them. For a project, we'll have a separate piping specification. And in that, you can pull out this data and you can input it. In this case, I just put it as standard. Okay, it could be 40, it could be 80, like that. There are various schedule actually, right? Then piping material and spec. Again, this is also we need to take from piping team actually. Okay, so in this case, what I put an example is carbon steel, CS. And of course, is there any stream trace requirement? We need to also highlight here actually. Okay, friends, I think this is also clear. So now we have covered general information and pipeline details. Okay, now we will move on to the process conditions. Okay, so in the process conditions, as I highlighted earlier, there are items like 11 to 26. I mean, just for reference, I put this serial number. Of course, it depends on your company data sheet which you are working. So in this case, all these 11 to 26, you need to refer to the process data sheet received from process team and input the same. Okay, friends. Then very important. You may ask why this is in a blue font. Actually, whatever is highlighted in blue font, these are all the additional info I want to just feed in actually. Okay. So fire safe design. So in a project phase, we come out with the strategy or philosophy. So what is there any fire safe requirement is there? So if it is yes means you input this yes. And what is the standard adopted for this? So in this case, you need to refer to project spec and input applicable. Okay, if applicable. So for example, it should be in line with API RP 533. Okay. So all these, API, RP 533, what is that and all we will be discussing in a separate videos. I'll be covering that, you don't worry. Just now you remember this code reference. Okay. Then calculated results. So under calculated results, flow coefficient CV. Okay. Flow coefficient. That's called CV basically. Okay. So for the benefit of freshers, for the benefit of beginners, so I just want to tell you what is the CV. Okay. CV is nothing but the flow capability of a control valve at full open conditions relative to the pressure drop across the valve. Okay, friends. So just remember this definition. It is defined as a volume of water, that is GPM in US, gallons per minute in US, at 60°F that will flow through a fully open valve with a pressure differential of 1 psi across the valve. So this is the definition. Again, I repeat. So valve coefficient CV is the flow capability of a control valve at fully open condition related to the pressure drop across the valve. Meaning, it's defined as a volume of water, that is gallons per minute in US, at 60°F that will flow through a valve, fully open valve, with a pressure differential of 1 psi across the valve. So that's the definition. Of course, experienced engineers all know this. I just want to explain for the benefit of new friends. Okay. Okay. So basically, we need to specify the CV value based on the preliminary calculation obtained from either InstruCal or Conval. And of course, this will be confirmed with the vendor. Okay. How we are going to size the CV, all those will be dealing in a separate videos. Okay, friends. Okay. Now, the second item is this sound pressure level. What is the sound pressure level? Normally, the noise we should restrict less than 85 dBA. This is almost every refineries or every project we go with this requirement. Okay, of course we need to confirm with the vendor. Some cases when they do the sizing, it may go beyond 90. So in that case, we need to do a proper remedial action for the reducing this noise. Okay. So maybe insulation or maybe a different type of valve, noise reduction, trim, all those stuffs they need to consider. Okay. Then travel. Basically, this one actually vendor need to give. So just enter VTA. You can find a lot of VTA here. So VTA means vendor to advisor. So this travel basically it will confirm based on the calculations. What is the minimum travel percentage? For example, 10% is the minimum for the minimum flow. And what is the maximum flow percentage? Maybe it will go up to 85% or 90. So it all depends on the vendor calculations. Okay, friends. Then similarly, then selected results. So previously we discussed the calculated results. Now selected results. I just put this in blue font because this is an add-on actually. We can always have this information in this previous data also. But I just want to, explain to you in a separate item as a selected results. So in this flow coefficient. So in this flow coefficient, we need to see whether the selected CV is at least 1.2 times of the calculated CV. Okay. This is the general criteria usually followed, but of course you need to follow the project specification also, what is mentioned, because every project, every client or every end user has their own specification. Like you can see Saudi Aramco, Exxon Mobil, Shell, all these are okay. Then sound pressure level. So again, as I highlighted earlier, we need to verify this noise should be less than 85 dBA. Then travel, of course, selected travel as per the project requirements and of course as per the calculations. So this is about selected results, friends. Okay, now we go to the heart of the control valve. So this is body and trim. Okay, so body and trim. Okay, first manufacturer and model number. Of course, we will not know when we prepare the data sheet. We just put enter VTA. So vendor to advise. For example, Fisher EWT. For example, then body type. Here, one point I want to mention. Generally, we go with the global. That's a general use actually. But there are also other types of valves actually in industries actually. Okay. So how it is defined, so in basically we should see the process conditions. For example, the fluid properties, pressure drop across the valve, shutoff pressure required, and the stroke speed, application service, sound level of the valve, and the seat tightness, and of course economical advantage. Okay, in that sense, if you see a rotary valves, meaning eccentric plug or segmented valve, may substitute globe valve and use for slurry service. This point you remember, rotary valve, which is of eccentric plug or segmented valve, may substitute for globe valves and used for slurry services. So if you slurry service is there, if you know it's a for slurry service, you should go with rotary valves. Okay, friends. Then what happened to if the service is erosive and you have a high pressure drop? Okay, so if there is an erosive condition and a high pressure drop, you should use angle valves. Okay, this you should remember. Then also other type of valves, butterfly valve. Where the butterfly valve we use? Always remember butterfly valve we use in low pressure drop application. Of course, high flow rate. This also you maintain high flow rate requirement and low pressure drop requirement. If it is like that, you go with a butterfly valve. Of course, it is also used for corrosive services where body lining is required. Okay, friends, there are some other valves also. There are three-way valves. This is used for flow diversion or flow mixing. And ball valves also there. That's used generally for on-off service. Okay, friends, I think this information is very useful. Then we go with body and trim size. Okay. So basically here, again, the challenge is we need to enter this VTA because we need to get the info from vendor actually based on the calculation results. This one you leave it to vendor. Okay. Then number 38, rated CV and characteristics. So again, this is also the rated CV also based on the selected CV results. Okay, friends, that's for the rated CV. Then characteristic selection. So characteristics, there is a lot of, some criteria followed by different vendors and some based on the end users. Okay, I'm going to explain you some very easy criteria for the selection of characterization of valves. Okay, for example, you see the table here. Okay, this is the process variable: level, pressure, flow, temperature. Okay, friends. Then you remember this constant or dp at q max greater than 0.5 of dp at q minimum. What is dp? This is the pressure drop. Okay, pressure drop q max, meaning pressure drop at maximum flow, 0.5 pressure drop at minimum flow. Similarly here, pressure drop maximum flow less than 0.5 dp q minimum. You just remember these two conditions. Okay, for example, for a level, we will go with linear option, and pressure will go with linear option, flow will go with equal percentage, temperature equal percentage, if falls under this criteria. What criteria? Pressure drop at Q max greater than 0.5, that is 50% of pressure drop Q minimum. So if this condition satisfies, we use level linear, pressure linear, flow equal percentage, and temperature equal percentage. Otherwise, if the pressure drop at Q max less than 0.5% of, 0.5 means 50% of dp at Q minimum. Okay, Q minimum is minimum flow, or you follow this equal percentage. I hope this is also clear for you. Anything you can always write back to me. I'm willing to help you out. Okay, thank you, friends. This is also clear. Okay. Then we go to the body and trim, same end connection and rating. So here one challenge is also there. What is the challenge here? So we need to again refer to the piping material class. Okay, for this end connection and rating. One thing you see, there are some refinery, we always go for 30 pounds rating RF price plan for typical control valves. Typical control valve, we use the 300 pounds. And of course, for high pressure, we need to use 600 pounds. This is one thing you need to refer. Okay. Of course, some vendor, they follow, some client or end user, they follow 150 rating also. But based on my refinery experience, I can always suggest 300 pounds is a safer rating. Okay. That's about the end connection. Then we go to the body material. So body material, again, they refer to the piping material class. So in this case, ASTM A216 WCP. This is actually notation from the for the carbon steel actually. ASTM A216 WCP is a carbon steel. So in this case, carbon steel, for example. Then what is the bonnet type and material? Generally, we go with the standard bonnet, but there are some applications. Which we need to consider a extension or fin bonnet. Extension or fin bonnet. Where this extension and fin bonnet used actually. So this is where this will be used when the temperature exceeds 200 degree. Okay, exceed 200 degree. Okay, or below 0 degree. So in this case, we can use for the extension or fin bonnet type. Okay, friends. Just remember, of course, you need to align with the manufacturer recommendation. Okay, friends, I hope it is clear. Then material, again, you specify as per the piping class. In this case, I just put example carbon steel, which is ASTM A216WC. Okay, friends, thank you. Then flow direction. Flow direction is what it basically what it indicates. It specifies the direction of flow through the body. And of course, this is to be confirmed by the vendor, okay, during the calculations. And this has to be engraved in the valve body, that you remember. This specified direction flow through the body. Of course, VT, for example, I just put it as flow up, need to be confirmed from the vendor. Okay. Then gland packing. So gland packing, here also some specific class is there. Okay, specify material and type of packing as per the piping class. Okay, in this case, we can use PTFE, which is Teflon. Okay, if it is below 230 degrees centigrade. If it is above 230 degree, always we go with graphics. Okay, friends, I think gland packing also clear. Then we'll go on to body and trim, lubricator and isolation. Again, this is in a blue font. This is all additional added info. Lubricator and isolation valve, normally it won't be applicable. So specify not applicable. Okay. So basically to touch this, I want to add a little bit on this. So where this lubricator and isolation valve, lubricator application comes into picture, because some packing may require a periodical lubrication to function smoothly. Okay, so that time this kind of requirement needed, but of course we can always check with the vendor. Okay, then we'll go to the guiding guiding and number of port. Again, this one also we need to ask vendor. We need to put vendor to advise. For example, gauge guiding, top guided, all this data. You don't worry here. This topic is only to help you guys to go through how to prepare the data sheet. But this, gauge guide, top guide, all these will be dealing in a separate video when we talk about more on the about control valves. Okay, selection criteria, type of application, all these. At that time we will deal all these stuffs. Okay. So now we, next is the trim type. Okay. Of course, this is also in line with the piping class, or we can use VTA. My suggestion is go with the piping class. For example, single-seated, gauge-guided, multi-stage, double-seated, top-guided, all these. So we need to work closely with the vendor in line with the piping class. This one we need to check with the vendor for this. So just put VTA. Okay, vendor to advise and reconfirm. So here also I just want to add on some insights. So basically, what is trim? Of course, our experienced colleagues knows. But for the beginners, I just want to tell you. Basically, trim consists of plug, seat, and stem guide. These are the three: plug, seat, and stem guide. Okay. So trim construction will vary depending on the types of valve, characteristics of the plug, and the pressure drop across the valve, and the sound level. All these actually factors decide the trim type. Okay. So trim material should be minimum stainless steel, preferably either 304SS or 316SS, unless process requires higher grade material, maybe stellite, which may be even hardened type. So maybe we may go for that. So that's it. And of course, if there is a hardened material treatment is needed, then we need to go for a hardened material treatment. Okay. That's it for this trim type. Then we'll go with the plug ball and disc material. So this is actually specified as per the piping class. Again, 316SS, okay, or 13CR trim HF. This is a typical trim material actually, okay. Then seat material also in line with the piping spec. Example, 316SS hard face, Teflon, or 13CR trim HF. Okay, just for an example. Okay, friends. I hope this is clear. Seat material also. Then we go to the gauge guided bushing material. What is this? Basically, this one I think we need to depend on vendor. So you just specify it as a VTA. Okay. Then same body and trim. We move on to the stem material. Okay. This also you need to align with the piping class. Example 316SS. Then NACE compliance. So basically, this is actually National Association of Corrosion Engineers Association, where this NACE is normally deployed. This is used for a wet H2S service or source service. So basically, this should compliance to MR 0103, which is deals with material resistant to sulfide stress cracking in corrosive petroleum refining environment. So that is what wet H2S and source service. If it is applicable, you put applicable. Okay. Then gasket material. So the gasket material, we can specify, but of course we can ask the vendor to advise. See, normally we use graphite if it is more than 230 degrees centigrade. Okay, depends on the temperature requirement. Then stud bolt material, of course, this purely depends on the piping class. Example 316 SS. Then flow action 2. Okay, this one we need to specify VTA based on the flow direction and of course based on the calculation results. Then we go with the body color. So this is based on the project requirements. Okay, this is basically defined in the project specification. You can pull out the data. Okay, that's all about body and trim. Then we'll go to the actuator. Okay, actuator in the sense, what is that? Manufacturer and model. So we always specify vendor to advise. Okay, then type we can say whether we need a spring return or diaphragm type. Okay, or we can always say VTA also. Okay, friends. Then number 58, size and area. So again here, this based on purely on the final sizing. So we leave it to the vendor. Okay. Then we have some actuator IA design pressure, instrument air design pressure. This one again I put it in blue font. Normally they don't specify in the data sheet, but better to have it. Good to have, not must to have, good to have. So it should be based on the project specification. For example, 4.5 bar G. Okay. Then we all knew this air failure action. What is it? We need to refer P&ID. And of course, if you remember the P&ID course, you can see that fail open, fail close, fail lost. Okay. So refer the P&ID and pull out and input it here. Okay. Then again, failure, action on power failure. Of course, this is also same as item 60, unless vendor has some other, opinion. Actually, I don't think so. It should be both are 60 and 61 to be same actually. We should specify as so air action on power failure, action on power failure. So basically, when it is, if it is considered as FC, so it will close, it will go to the close position. If it is a FO type, then it will go to the open position. Then if it is FL, it will stay at the last input. Okay. Then one more thing here, hand wheel location. See, we also, this in the pipeline, you have a bypass, all these there. But in case the valve got stuck, you need to, open to meet the process demand. So you need to have this hand wheel location. So predominantly we go with the side mounted, or of course you can follow the what is specified in the project specifications. Okay, friends. Okay. Then few more on actuator bench range. So bench range you specify as VTA, vendor to advise, then actuator color. So this is based on the project specification. For example, fail close red, fail open green, or fail lost yellow. Of course, it depends. Then travel limit stop. So if there is a travel limit stop requirement, you just put it as yes. It is also in line with project specification. Okay. For example, some vendor or some requirement will only allow maximum 90% or 85%. So in that case, we put that stop actually travel limit. Okay. Then fireproofing requirement. So this is also purely depends on the project requirement, exclusively the HSE, health safety requirement. So basically you need to refer HSE requirement specification requirements for this. So in this case, I put yes. Then IP rating as per project specification, I just put typical 55 or maybe 66. Yeah, all these stuffs. Then volume tank for fail position. Okay. So this also you need to see actually what is your requirement. Don't specify VTA. Vendor will advise actually if there is any requirement for a failed position. Basically, I think for a single cycle it's not required, but it depends. Then also, yeah, volume tank for a additional stroke. So this is actually a challenge actually. Challenge the sense, so it depends again on the project requirement. So you put yes. For this case, I put yes. Okay. Okay, friends. Then what else? What else we can cover? Yeah, I think mostly we covered. Yeah. So basically, yes. If you talk about something on the volume tank, basically this is used for a fail action of control valve when losing the instrument as supply. So that is where you take care. But normally, in a plant system, we will come across this very rare scenario only. But if it is very critical, all this failure mode, then we look into this volume tank requirement. Otherwise, we just good to go with the plant as system. Okay. Then we have a lifting hook actually. That is, when we transport the valve, you need to have a hook. So that is actually okay. That's a very common thing we can put it. And travel indicator. This is also, for monitoring the position, whether you want this as a travel indication or not. So if you want to put it, you put it. Of course, you go with the project specification. So that's it about the actuator, friends. I hope this is also clear for you. Then we'll go on to communication and software. So what is this communication? So basically we need to adapt the project specification. For example, either HART with standard analog signal or a foundation field bus. Okay, what is HART? Of course, for beginners, HART, highway addressable remote transducer. Okay, FF is foundation field bus. Then function block requirement. This is also applicable only for foundation field bus. Otherwise, you put not applicable. Then we have a valve asset management software. This is also, we need to specify VTA. We need a vendor need to get software, make, model, version, etc. Then we have a compatibility with the PAS. What is PAS? A plant automation system. So we just put a specify VTA. Then last capable, that is link acting scheduler. That is also we need to specify VTA. Okay, it's applicable purely for foundation field bus only. Then DD revision, ITK, all these stuffs. DD revision, ITK also, no? This is also related to field bus things. Okay, friends. I hope this is also clear. Basically, ITK means interoperability test kit. Okay. So what is it actually? It verifies the functionality of a device with the foundation field bus function block specification. Okay. So these are actually test kit actually include hardware, software required to ensure manufacturer's complete device interoperability. What is interoperability? Meaning any type of device can be communicated with any type of system. So that kind of technological development has come in. So this just you mention it, that's it. Of course, we need to specify VTA applicable only for foundation field bus. Okay, friends. So then we go into the positioner. Okay. So positioner, of course, again, manufacturer model, specify VTA, signal, specify either 4 to 20 milliamp hour or foundation field bus, depends on project spec. Then 80, increasing signal value. Okay, here one thing, you specify open for fail close type of application and close for fail open application. This is what you need to put in this data sheet for the positioner. Okay, then CAM characteristics. Generally, we go with this linear requirements. Or in some cases, project calls for a different thing. You go as per the project requirement. But generally, we specify as a linear actually. Okay. Then also some bypass and gauges. Bypass requirement not applicable. Yeah. Because, if a pneumatic positioner used, we need to specify whether bypass is required or not. Okay, that's it. Here in this case, it's not applicable. So positioner bypass should not be provided. Normally, positioner bypass we don't provide actually. So of course, if it is a pneumatic positioner, we need to specify here. And of course, gauge, we need this. And 83, what is that? Electrical connection. This one you specify M20 or in line with project specification. Then 84, this is a certification IP degree. Here, there are a lot of things we need to consider. We can specify either EXIA, EXIB, or EXD, whatever is based on the specific requirements. And IP rating, it's of course IP 66, for example. Okay. Then external position transmitter. External position transmitter. Is it needed or not? If it is needed, you put yes. Of course, this is as per the project requirements. So that's all about positioner. Then we go with the solenoid valve. Okay, friends, you fill in only if applicable, because most of the cases we don't require this unless the special requirements calls for the solenoid valve for actuation. Okay. So again, the manufacturer model, you specify ITA, VTA, type and quantity, specify VTA, de-energized valve as per the project requirements. Okay. Then, yeah. Basically here, what is the point is here, specify valve stroke direction when solenoid is energized. So basically it is recommended to adopt normally energized circuitry unless specifically specified as energized to open or close the valve for special application such as FGS. So this is the point you need to check. So I again repeat, specify valve stroke direction when solenoid is energized. Okay. So it is recommended normally to adopt the energized circuitry. Okay. Unless there is a specific requirement like energized to open. Okay. Or close the valve for special applications such as FGS. Anyway, you don't bother much on this. You just put it as yes or no based on the requirement. Then, of course, this is as per P and ID. Yeah, tag number as per P&ID or assign the tag as per the project tagging convention. Power consumption, this is 24 volt DC. Then again, what is this? External reset voltage rating. External reset requirement as per project requirements, and voltage rating, of course, it is 24 volt DC actually. Okay, friends. Then speed controller, not applicable. Certification and IP rating, of course, is again in line with EXIA, EXIB, all these stuffs. And you have to, put the IP rating, for example, yeah, as this one, as a IP rating. Okay. So that's it about the solenoid, and a few more contents also there. Housing material. Of course, this is also again purely depends on the project requirements. For example, yeah, for example, brass in this case. Then electric connection, specify M20, coil insulation rating as per project requirements. Yeah, that's it about solenoid valve, friends. Okay. Then we go to the switches. Again, manufacturer model, specify as VTA. Then 98 type and quantity, specify VTA. Remember, this one is very rare case, so fill in only if applicable. Contacts SPDT as per the project requirements. Okay, SPDT as per the project requirement. What is SPDT? Single pole, double throw. Then switching position. So here also you specify either close at valve open position or close at valve close. You specify either close at valve open position and close at valve close position. Okay, friends? Yeah. Tag number again, this is in line with P&AD or in the project tagging convention. Okay. Quantity depends as per the P&AD, and certification, IP rating, all these also as per the P&ID. I mean, not as per the project requirements. And of course, IP rating is IP66, you can specify actually. Okay. So this EXIA, all this we will check, I mean, do in a different, what do you call, in a different topics actually. Okay. So the point is, see, this is basically EXIA, this is intrinsically safe protection. So this used for, instruments in zone 0, zone 1 or zone 2 location actually. So EXD in the sense it gives the flame-proof protection for equipments installed in zone 1 or zone 2 locations. So this is the point actually here. Okay. Of course, we will discuss the detail actually in a different topics. Then electric connection M20 or project specification. Then housing material as per project specification. I just put it as SS. Okay. Okay, friends, I think you all got some good insight on the switches also. Then we'll move on to what is that? Asset. This air filter regulator, manufacturer model, specify VTA, and yeah, one set pressure, specify VTA. Of course, if you remember the earlier slide, we put it as a 4.5 as the instrument air pressure. So the same thing we can put here or even higher than that set pressure. Of course, it depends on the vendor recommendation also. Okay. Then filter input and output range. Yes. Specify yes for both. Okay. Filter is needed and input and output also needed. Okay. Then housing material. Of course, normally, yeah, we go with aluminum, but of course, it go with the project requirements. Okay. Then adjustment screw drain net material. This should be SS316 and pressure relieving type and drain. Yes, we need a pressure relieving type and also drain is needed. You specify both and filter size. This one is specified as a 5 micron. Okay, okay, friends. I think this is also clear. So now we have concluded our set. Now we go with some miscellaneous things, purchase. So basically in the purchase, what do you call it, put manufacturer as VTA and model also VTA, requisition number also, of course, this is based on your requisition references and purchase order is based on the PO references. This is just a simple commercial things. Then finally, the last but not the least, the special requirements, friends, is very, very important actually. Okay, because normally we don't specify. If we don't specify, we will not get it. Okay, so better to specify. Okay, let's get started. What are the special requirements? Material certificate according to ISO. Yes, I need this. Positive material identification, PMI report. Yes, I need this. EMC standard according to IEC 61000 series. Yes, I need this. Hydrostatic pressure report. Yes, I need this. Customer configuration report. Yes, I need this. Calibration test report. Yes, I need this. Electric hazardous classification again. Yes, I need this. Then SIL classification. If anything is used for safety application, you should always go for SIL. So nowadays it's minimum SIL 3. Of course, it depends on the project requirements. Okay. Travel limit stop on percentage indication and actual nameplate. Yes, it is needed means you put as hydrogen service requirement is there. If you remember the wet hydrogen service, NAS compliance, yes, you put it. Cryogenic test report needed. This is for the cryogenic valve. This for the temperature below 0 degree. Okay, negative and 0. So there we will use this cryogenic application. Yes. Fugitive emissions. If it is fugitive emission, as per ISO 158481 or APA 622, you put this. Yes, sir. This is all the very typical, requirements in a typical, what do you call, refinery application. That is why I just put all these from that reference actually. If it is not required, then you don't have to worry actually. Don't have to worry. Okay. So here you may think, what is this fugitive emission actually, right? So you may be having the thoughts. So basically, this fugitive emissions or leaks and other irregular release of gases or vapors from a pressurized equipment, pressurized containment, basically like a storage tank, pipelines, all these stuff. So you need to have that criteria, how much is leakage is allowable, all these stuff. So if we need to comply to this, then you need to go with this requirement actually. They need to give the certificate. Okay, friends. What is the details about fugitive emission, other stuffs, all will deal with a different topic in a control valve applications. Okay, friends. There are some criteria which involve, which is related to the greenhouse effect or all these upstream, downstream industrial requirements. Okay. Then we have this safety shield required. Okay, yes, safety shield is required and stroke tank mainly. So if it is want to specify, for example, you see an anti-surge controller requirement or any process which needs very fast action, then you need to specify that clearly here. Okay, otherwise you will end up in a big, challenge at a later phase actually. So you need to specify that also. I put it as 2. Then again, the special requirements as we discussed earlier, volume tank as per ASME section 8 division 1, yes. Volume tank capacity. So what is how many strokes? Yes, in this case, I need a 6 strokes and fireproofing, meaning without the supply of supply cutoff, will still the valve will work for the 6 strokes actually. So that is a very critical valve. Will go with this kind of requirement. Fireproofing, yes. Functional test report with valve signature, that is yes. Manufacturer nameplate for valve actuator, yes. Then tap plate, yes. 2 years spare parts if it is needed, yes. Documentation, yes. Air tubing fitting material should be SS316. Yeah, this one very clear because in a recent project, the vendor, say I will use only nylon tube. This is, polyurethane 6 tube. So, better to specify here upfront so that we'll not get that kind of, very crazy things actually. Okay. Then diffuser silencer provided. Of course, this is VTA. Positioner ramping function, yes, needed. What is the ramping rate? You specify 5% per second. And gland packing requirement, yes. Pre-inspection meeting required, yes. Design review required, yes. FAT owner witness required, yes. Valve leakage report required as per FCI 72. Okay. So all these things you need to put it here. Okay, friends. I hope you had a very, very, very good insight on how to prepare a data sheet. Okay. Thank you so much for your support. Thank you so much for your, patience. Uh, Keep supporting. Many more videos are in pipeline. I'll be doing it one by one. Just purely with the intent of giving back the acquired skills to the society. That's the only intent, friends. I just want to recollect what we discussed. So now we know how to prepare data sheet. A data sheet in the sense how to fill in the general information, how to fill in the pipeline details, how to fill in the process conditions, how to fill in the calculated results, how to fill in the selected results, then how to fill in the data related to body and trim, how to fill in the data related to actuator, how to fill in the data related to communication and software, positioner details, solenoid valve details, switches details, asset regulator details, purchase requirements, and of course, the last but not the least, various special requirements. Thank you once again. See you. Bye. This is Rambala. Thank you.